Hi everyone, I'm Hải Đăng Nguyễn. I'm currently a master student at Eurocom, but I work with two excellent undergrad students from Ho Chi Minh University of Science, Trung Hiếu Hoàng and Thành Năng Nguyễn, Supervisor Vinh Tiệp Nguyễn, and my Professor Minh Triết Trần. Today I'm gonna present our work in which we apply residual neural network and faster RCNN for the medical task. And here's our content outline. I'm gonna move directly into our approach. As you know, the task was about classifying endoscopic images. So it's all about image classification. So we think that residual neural network has the power to do that. However, after a few times doing experiments with the residual neural network, we found some specific classes where that contain the images where the symptoms of abnormal disease appear as small objects in the image, and ResNet usually fail to classify them correctly. So that's why we need the faster region-based convolutional neural network, faster RCNN, to detect these small objects and reclassify the images of those classes that the ResNet usually misclassify. But in order for the faster RCNN to be trained, we need to manually tag the signal of disease in the following classes. We decided to choose dye resection machine, dye lifted polyps and instrument. We manually draw the bounding box around the objects. For example, here's the bounding box around the polyps, the resection machine, and the instruments. And besides, we also found some images in the data set belonging to multiple classes. For example, the left image, it contains both the polyps and the instrument, and on the right, the image contains the signal of ulcerative colitis, and the instrument also. But according to the given priority list, their original labels are inappropriate, so we decided to relabel these kinds of images. And we also see that there's a very small number of images in the instrument class, only 36 images. So in order to maintain the balancing between the classes and to improve the diversity of the instrument images, we manually extract the instrument objects from the original image, and then we place these objects on the different backgrounds. The backgrounds taken from the dye-lifted polyps, the resection machine, the polyps, and ulcerative colitis, and these are the augmented images for the instrument dataset. And here's how we train our model. We use the residual neural network with 101 layers and faster RCNN, both pre-trained on the ImageNet, and we fine-tune them on our datasets. So now we have a different dataset, the original one and the one that we modified. And then we perform knowledge transferring by fine-tuning the model. In this task, we submitted multiple runs with different configuration of our models. And here's our first run. The ResNet 101 and the faster RCNN, we fine-tune them on the original dataset with the instrument augmented dataset. And for the prediction phase for an image after going through the ResNet, if if it was predicted as the instrument or dilifted polyps or resection machine or ulcerative colitis, they will go through the faster CNN in order to detect the objects in the image, and the faster CNN we do the double check for the instrument. If the instrument is found from in the image, the image will be reclassified into the second Higgett. Will be reclassified into the image, the instrument, and if the instrument not found in the image, then we relabel it as the class of it, the second Higgett score proposed by the ResNet. And here's our second run, because the faster CNN took a lot of time processing the image, so we limited the number of image go through it by ignoring the second case comparing to the first run. So we just ignore the second case, and it's actually boosts the system a lot. We accelerate a lot in the result. We can see it. And for the third run, this is our best run. We perform training our models on the modified dataset, and everything is just the same as the second runs. And this is our run 4. In this run we perform training our models by using only 75% training dataset. And in run 5, we because we when evaluating our models, we realize that there is a confusion between the esophagitis and the normal Z-line after they are predicted as the ResNet. So we add a small bias, 0.3 to the probability of the esophagitis slot if the normal Z-line was predicted by the ResNet. So it intuitively means that the ResNet model refer the esophagitis to the normal Z-line. And here's our run description in words. And so I skip it. And this is our result. So as you can see, in run 3 we achieved the best performance, but the run 2 we have a very high speed. We achieve 23 frames per second in with run 2. And we test our system on the Tesla K80 GPU. And here's the confusion matrix of our best run 3. As you can see, there's still confusion between the esophagitis and the normal Z-line class. So to conclude, so we may need more data, more training data for these two classes if we want to overcome this issue, or we may need a more robust approach to solve the problem. Thank you for listening.